All right, the time now is 11:02 p.m. and I will just be doing a quick video because actually I've solved this combination sum problem. Yeah, so today wasn't really feeling good, but decided to go through with this and use the hints and looked at a bit at the solution, trying to figure out work backwards. So let's go. So you are given an array of distinct integers, nums, and target integer target. Your task is to return a list of all unique combinations of nums, unique combinations, where the chosen numbers sum to target. The same number may be chosen from nums an unlimited number of times, but you must have a unique combination. Okay? So two combinations are the same if the frequency of each of the chosen numbers is the same. Otherwise, they are different. You may return the combinations in any order, and the order of numbers in each combination can be in any order. Okay, so basically, the internal ordering of the answer doesn't matter. Yeah, but, but, so 225 implies that 2 and 2 can be used multiple times, but 252 would not be a valid combination. So, okay, great. So here we have 33334. 3355, but 3535 will not be, it will be just be a duplicate of this. Okay, so as you can see, the numbers, distinct numbers are not very big. In fact, they are just up to 20 distinct numbers. And the nums I can be up to 30 as well. And the target is also up to 30 as well. Okay, so let's see. This is a backtracking question. The time complexity is in exponential time. OT 2 to the power of T over M and OT over M space where T is the given target and M is the minimum value in the given array. So I mean this pretty much makes sense, right? You take the target divided by M, which is the minimum number, is the number of times you have to recursively call this. So from this exponential term, we can see that a brute force solution is pretty much what we want to do. So the height of the tree is around OT over M, and the solution will be 2 to the power of T over M. Okay, cool. So we'll look at it in terms of a decision tree, and we have n decisions where n is the size of the array. Okay, it's the size of the array of numbers that you have to use. Okay, in this decision tree, you can observe different combinations. Okay, so if let's say I want to find target 9, I can take 2, 5, 6, or 9 as my first number and then carry on. The base condition would be when, if let's say, okay, so how to approach this question is to take a look at it from a depth first search point of view, where you go down one path. Let's say you take all the two. It's something like the coin change, right? Where you just keep taking two until you can't, until you hit 10, and then you realize that it's the number is greater than the target, and then you won't do anything about it. But the idea is to backtrack. So we will use DFS, but we'll do it in a pre-order traversal way, where we will process first, okay? And then we will uh either push it to the result, the answer, if it matches, or we will push the number that is still valid, and then we run DFS on it. And then this current dot pop is how backtracking is done. Okay, so basically it's like you're going down two until you can't, and then you backtrack, and then you try to do 5, and then exit, and you backtrack to do 6. Yeah. So how to do it? For what we do is we add each number recursively. So I mean this is pretty straightforward. If total is equals to target, then we will just meaning the total sum within this combination. is equals to the target, we will just push this combination to rest and return. Okay, that's the recursive base case. Next, we will open up a loop where j is equals to I. So take note, there is this I here, which is specified here as one of the parameters. So why do we use j is equals to I, right? There are two reasons. So notice how j is I, but initially, what is I specified to be? 0, because that's index 0 that we're using, the first number. Okay, so before that, we will sort everything out first because we cannot assume that it's sorted. We'll sort in ascending order, meaning we'll just get 2, 5, 6, 9, and 3, 4, 5. Okay, so what this does essentially is to first prune the decision tree, because you have a heuristic, right? Where if let's say you're already on 5, you cannot go back to 2 because you will have to choose a bigger number, because you would have considered if 2 was supposed to be the combination, but you busted, right? Yeah. So the second one that you might not, that I didn't notice at first, because pretty much I was just doing like I equals to 0, nums length, plus I, right? And then I was just looping through everything. You start to get duplicate sets, because you will go to 2, and then you will get 2, 2, 5 as the first one, and then you will get 2, 5, 2, because you are exposing all possible numbers of it. And you would have to do some additional processing to remove duplicates, which makes it a lot slower. So if you were to sort it first, and then you do a decision tree pruning, right, you can actually eliminate duplicates, which is something that you want because you want all unique combinations of nums. Cool. So pretty much we are running from starting from index I using the smallest number, empty array of cur, which is basically what you're building the answer with. And then what you do, if total, the total starts from 0, right? So if the total plus the number is greater than the target, then you will pop. If not, what you will do is you do current dot push the number itself, which is in this case 2. Then you do DFS on it. So DFS with index j is equals to 0, because you're taking the first number, remember, index 0. The current itself, which is already has 1, 2 inside, and total plus nums j, which is just 0 plus 2 and 2. So in this next case, 2 is not equals to 9, so we don't care. So we will let j go to 0 again. This one we will skip because we haven't reached it. So current push 2 again, so it's 2, 2, and then DFS will run 0, 2, 2, total plus nums j, which is because of 4 now, and current dot pop. Yeah, sorry, ignore the current dot pop. We'll do DFS again, and then it'll be DFS 0, 2, 2, 4. And then 4 is not equal to 9, so we will ignore that. And then we'll start from 0 again. This one we'll ignore. 2, 2, 2. And then we'll run 0, 2, 2, 2, 6. Go in here again. 2. So 0, 2, 2, 2, 2, 8. Go in here. Boom. 8 plus 2 is more than target, we'll return. So at this point, we'll return to the previous stack, which is 2, 2, 2. And then we'll pop. So 2, 2, 2, 2 will become 2, 2, 2. And then we'll go into the next loop of the for loop. So it become 1. J will become 1. We'll look at total 6 plus 5, which is index 1. More than target, return. Then we'll return the previous time, it will pop. So current will go from 2, 2, 2 to 2, 2. Okay? And then what we will do is j will be equals to 1, because that root returned early, right? So j is equals to 1. We'll do 2, 2 plus 5. Okay? 2, 2 plus 5 is not greater than 9, because 9 is not greater than 9. We'll add 5 to this, and then we'll do DFS. And once you do it, you enter here, and 2, 2, 5 will be a valid result. Yeah. So just for sanity check, we'll just console.log then we'll console.log. So we get 2, 2, 2 as mentioned, 2, 2, 2, 2, 2, 2. This is where we add another 2, it'll return and it'll pop. So we go back to 2, 2, 2. And then it'll pop again because 2, 2, 2 plus 5 will still be bigger than target. With 2, 2, and then 2, 2, 5. Okay? And then once it's bigger, we'll go back and then we'll pop 5, and then we'll try to 2, 6, which will cause it to pop again, become 2. And then we'll get 2, 5. But in this case, if let's say we were to expose j equals to 0 instead of I, we will get back 2, 5, 2, which is a valid combination but not unique, which is why we don't want to do that. And then 2 plus 5 is bigger than 9, so we'll pop, become 2. 2, 6. 2 plus 6 is also bigger than the target, so we'll pop on 2. So 2 plus 9 also too bigger, we'll pop empty array. And then we'll jump to 5. 5 plus 5, pop. 6 plus 6, pop. 9 itself is the target, so we'll push and then we'll pop. Because 9 plus 9 is not valid. And then we'll out the loop. Okay? So if we were to submit this code, it should work. Awesome. So yeah, that's just it for today. Goodbye.